Hi, and welcome to Chapter 2. Today we're going to start talking about the properties of matter. Now this is going to be very important because we mentioned before that chemistry is the study of matter and its properties. So this is chemistry. Let's start thinking about something we're all familiar with. We're all familiar with glass. Did you ever wonder why windows are made of glass? I'm sure you have, especially if you threw a baseball at them. Did it bounce off? Or did it land in someone's living room? Did that old man chase you down the block? How come? Well, we all know that glass is transparent. It's hard and it's durable, but it's still fragile. But it was able to go into that nice window in that house so that someone could look out and see the light coming in. But it was a little expensive after you broke that window, wasn't it? So those properties of glass are just properties of one substance that we're going to talk about this year. Now, one of the things we're going to talk about two different types of properties. One of them is called intensive properties. An intensive property is a property of a substance that is the same no matter how much of that substance you have. So it is going to be the same no matter how much you have. So we're going to talk about that for a little bit. Some of the things you might look at when you look at a particular sample, you may ask your questions about its characteristics. We already know one characteristic we studied that's an intensive property. That was density. Some of the other things we might think about is its luster. Luster is a word that you might have heard as being how shiny something is. Luster is shiny. So is it shiny or is it dull? If it's a liquid, does it flow like maple syrup? Or does it flow like a waterfall of water? If it's a gas, does it smell? Or is it odorless like oxygen? These are all properties that are the same regardless of the amount of substance. So I mentioned there were two types of properties. I've already mentioned some things that are called intensive properties. There's also another type called extensive properties. So extensive properties depend on the amount of matter. For instance, I've mentioned to you before that if you had a liter of gasoline or 10 gallons of gasoline, which one would have more energy? If you said the 10 gallons of gasoline, you would be correct. That's a lot more gasoline. Now, what if I said, is gasoline a volatile liquid at room temperature? Your answer would be yes. It doesn't matter if you have a liter or 10 liters. It's still going to be volatile. That's a characteristic or property that could be an intensive property. Now, how do we measure different things? We've measured things in the lab, such as mass. Now, we can look at two different balls. We can look at a golf ball and a basketball. If we look at the golf ball, we know that a golf ball is right here. It's kind of small versus this big basketball. So just by looking at it, well, one thing we can say is the volume that this golf ball takes up versus this basketball is a lot less. But we also know that the mass of a basketball is a lot more than a golf ball. So the mass of the object depends on the amount of matter. So if we look here, here's mass, it has to do with amount. So since it has to do with amount, it must be an extensive property. Okay? So I also mentioned volume. Okay? So the volume of the basketball is a lot greater than the golf ball. So the volume is the space occupied. Oops, let me go back. The space occupied by the object. Now, towards the end of this video, we will have some vocabulary words, but make sure, if you're not sure, stop the tape when we come to these words and write down these definitions. They're very important for the whole year. All right, let's continue. Now, mass and volume, as I said, are both extensive properties. So what is an extensive property? It depends on the amount of the substance. So let's make sure we have that. Again, extensive, the key word is amount. If you can remember that, you can get the difference between intensive. I like to use the word intensive because in means inside, and when you think of inside, it doesn't change so much. Extensive is outside, so it gets bigger, bigger, bigger if there's a lot of it. So therefore, I think that's how I remember it. Okay? All right, now let's go back to the basketball again. We can look at some intensive properties that the substances that make the basketball up may have been chosen because of their intensive property. For instance, a basketball could be made out of leather or rubber or some synthetic composite of those. But why are they chosen? And one thing would be their robustness. Okay, they might not get as wet very easily and draw in the water so much if they were playing on a wet surface. But they basically, either of these three things could be chosen for a basketball because the characteristics of these substances make it a good choice for a ball that has to bounce and be used both on a wooden court, a composite court, or outside on mercaptan. For instance, leather balls would be very good for inside, but leather will absorb water. So it's better to have the rubber ball outside. Leather will also absorb dirt and pick up some more mass maybe, and maybe it won't be as easy or people can hold on to it and it might not be fair in the game. Okay, now absorbency. That means if you ever think of the commercials on TV for some paper towel commercials, they talk about absorbency. You know what that means. Absorbency is the ability for something to attract liquids. Okay, so that would be an intensive property. How absorbent something is would be an intensive property. So paper towels tend to be absorbent. Rubber, on the other hand, tends not to be absorbent. So maybe rubber would be a very good thing to use when something is possibly going to get wet. That rubber would be something that would keep it from being wet. Okay, so an intensive property, again, is something that is true no matter what. Okay, for any quantity of matter. So it does not depends not on the amount of matter. All right, why are intensive properties important to the chemist? Well, if we look at two different containers, a soda can and a watering can. The soda can, you should know, is made out of aluminum. Most soda cans are made out of aluminum. The watering can in the picture is made out of copper. Now, there's some reason for it. I mean, one of the things we can see with the soda can is, look at what's happened after they drank the soda. Somebody thought it would be funny to like crush it a little bit. This is a characteristic of aluminum. It's light, it's lightweight, it can be crushed very easily. Copper, on the other hand, can be hammered into shape, but it kind of stays that way unless you really do something with a hammer or something with it. And it may have been chosen for its characteristics. Okay, so they have there's some similarities and there's some differences between the two. Okay, now, what makes one form of matter different than another form of matter? Well, this is how we get into the idea of substances. Okay, and in the idea of substances, we're going to, if I can get the pen again, it's too far down there. There we go. A substance here is uniform and definite composition. So matter that is uniform, it's the same throughout, in other words, and the way it's put together is the same. So for instance, if it's a compound, it's the same amount of different atoms of different elements. If it's a pure substance, it's how it's put together. Now, both aluminum and copper are examples of substances. They're also called elements. And they're also called pure substances. Now, this is a very important word that we want to talk about in chemistry. In everyday English, when we talk about pure, you might have heard things like, oh, you can buy pure Florida orange juice. Okay? Well, according to the chemistry definition, that is not pure. And why isn't it pure? Well, orange juice is almost entirely water. Yep, that's it. It's almost entirely water. And then we've got some juice in there from the OJ plant. Okay, the OJ plant, the orange tree. The orange is mostly water. Okay, so there's flavorings that it produces and some sugar. So far I've got three things. I've got the water, I've got the flavorings that's familiar with you for the smell of oranges, the taste of oranges, and I've got sugar that grows inside the orange. So we've got at least three substances. I haven't even talked about pulp yet. Okay, so pure orange juice, in normal English, we're just saying that it's from the orange directly. But as far as a chemical idea of purity, it would be not a pure substance. It would be several substances put together. So we have to be careful and understand that there's words in chemistry that we might use in language arts class or in history class that are much more specific in chemistry. Okay? And pure is one of them. Okay, so if we have a substance and we give you sample A 5 grams and sample B 10 grams, the intensive properties of both samples are the same. Intensive properties do not change for a given substance. That helps us to identify which substance we actually have. Okay, so let's look at that. This helps us identify, I'll just write ID, different different substances. And when we talked about different chemists before, we talked about analytical chemists. Well, that's what analytical chemists do. They find out some of the intensive properties, like density, and they're able to identify one substance from another substance. So this is a very important part of chemistry. All right, let's go back to our aluminum copper examples. They have a lot of things in common. They're metals, okay? So they have things that are very similar. I mean, both of them, we can make sheets of copper. We can make sheets of aluminum. So we can press them out or hammer them out. Aluminum, we know, can be polished very nicely and can be very reflective. And sometimes they put it in aluminum paint, a silver paint. Copper is harder than aluminum, and it can scratch the surface of aluminum. So hardness is an intensive property of a solid. Copper is also a very good conductor of electricity and heat. It's why a lot of wiring is made out of copper. Aluminum is not as good of a conductor. And I mentioned the word malleable before. Malleable means it can be hammered into sheets or hammered into a shape, and it doesn't break. A really good example of this is gold. If you ever seen a steeple or a dome that has a golden dome, it's not pure gold. It's what we call gold foil. Someone has meticulously hammered that gold into sheets that are thinner than paper. And they've very carefully placed them on the surface and spread them out so that you see that beautiful reflective gold throughout the skyline. So gold foil is something that's applied, and because it's so thin, it sticks very nicely to that. It has to be replaced every once in a while, but that's because someone or a machine these days has hammered it out into very, very thin sheets. Okay, let's think of some things that are intensive property. I mentioned hardness. I said that copper could scratch aluminum, so hardness is one. Okay, color. Aluminum is kind of silvery. A lot of metals are silvery. Copper is unique because it's that we want to call it copper color, but it's kind of a brown, right? A ruddy color is a good way of saying that. Conductivity, how well it conducts electricity and heat. Malleability, how well it can be hammered into really, really thin sheets. Now we know we can make gold foil, we know we can make aluminum foil, and we can make copper foil too. So these are examples of physical properties, the properties of substances that are considered to be physical. They're the same substance, so I'm going to write that down. They're the same substance. Okay, they're the same substance after we do these things to it. It just may look differently. So a physical property is a quality or condition of a substance that can be observed or measured without changing the substance composition. So it's the same thing. In other words, we don't change the composition. In other words, we don't change it to some other substance. All right, this table here has some physical properties of different substances. We have some gases, we have some liquids, and we have some solids. I've listed the colors or the lack of color that these substances have. I've also said the melting point and the boiling point. Now, since I've given them a term gas, liquid, and solid, that's what appears at room temperature. So you'll see the gases have a very, very low boiling point. So at room temperature, they're going to be gases, whereas the solids have a very, very high melting point. And the liquids are intermediate. So if we saw a table of melting points and boiling points, and I didn't tell you what state of matter it was, and asked you what state of matter is this at room temperature, you would have to know what room temperature was. So about 20 degrees Celsius to maybe 25 degrees Celsius is room temperature. Now, if it's a little colder, like when the air conditioners are really cranking in here, then it might be a little lower than 20 degrees. And on those days when the air conditioner isn't working, it might be closer to 30, 35 degrees, unfortunately, sometimes. Okay? So that's your range. Your range probably is somewhere between 15 and 35, more likely right around 20, okay, is room temperature. So water is in the sweet spot, 0 to 100 degrees, okay? Do you know what body temperature is in Celsius? It's 37.5 degrees. That will be an important thing to know later on. Okay, as I said, analytical chemists use physical properties to define what substance they have. Okay, so if you had a liquid substance that was found to melt at 0 and boil at 100 degrees, that is the characteristics for water if we looked it up on the table. If we had something that boiled at 78 degrees and froze much lower at minus 117 degrees, it wouldn't be water. it would most likely be ethanol from the table we just saw. Okay, this is a question I asked a little earlier. And I'll put this on a question and be back in a second.